all, this video is all about clock signals in embedded system design. So clock signal will be generated by the oscillators, master clock, M clock. It will be used by the CPU and a few peripherals. So clock signals will be generated inside MSP430. This clock signal will be supplied by the DCO, digital controlled oscillator, with a frequency of about 1.1 megahertz. And the clock signal will be stabilized by means of PLL. Master clock signal is a software selectable as LF cross T1 clock and VLO clock and DCO clock signals. So here is a block diagram, basic clock source. So we have a VLO clock in the top, LFXT1 oscillator in the bottom, DCO oscillator with generators and filters and modulators in the bottom. And master clock is nothing but the one which is there in the right side. Auxiliary clock is there above the master clock. Clock signal is of another type and which is nothing but subsystem master clock. It will be distributed to peripherals, often same as master clock. It is supplied by the DCO with a frequency of around 1.1 megahertz. It is stabilized by PLL. SM clock is a software selectable as LF cross T1 clock, VLO clock, DCO clock, which is in a microcontroller. So this is the SM clock, subsystem clock. The third one is the auxiliary clock. I have mentioned in the diagram already. It is distributed among peripherals sourced from LFXT1 clock or CLK, typically much slower and usually less than 62 kHz of frequency. Auxiliary clock is software selectable as LFXT1 clock or VLO clock. Calibrated frequencies of DCO. The four possible calibrated frequencies of the DCO are 1 megahertz, 8 megahertz, and 12 megahertz, and also 16 megahertz. Crystals are usually used when an accurate, stable frequency is needed. Crystals are cut from carefully grown high-quality quartz with specific orientations to give them high stability. Traditional crystals oscillate at a frequency of a few megahertz, machined into complicated tuning fork shapes to give the low frequency. Designed to be more stable at 25 clock. Crystal connected between X input and X output. Crystals are important devices in the microcontrollers along with the clock signal. Disadvantages of crystal. Frequency is more sensitive to temperature. So solution, what to do? External oscillator can be used. Requires a capacitance to ground from each pin. So if we want to make the sensitivity less, then the only possible way is adding a capacitor to the ground. Value depends on the crystal and is typically between 10 pf or 22 pf. Capacitance value. Part of it contributed by stray capacitance from PCB track, therefore kept short. External capacitance needed for many controllers, RTC, ICCs, but integrated in MSP430. So clock registers are there, DCO control registers, basic clock system control registers R1, basic clock system control registers R2, basic clock system control register R3s are also used. So DCO-X is available, MOD-X is available. XTS, DIVA reset pins are available. Frequency of a DCO clock is set by the following functions. 4 RSEL cross bits select one of the 16 nominal frequencies ranges for in the DCO. These ranges are defined in the data sheets. The 3 DCO-X divides the data, divides the signals in the DCO range selected by the RSEL cross bits into 8 frequency steps separated approximately by 10%. The 5 MODEX bits switch between the frequency selected by the DCOX bits and the next higher frequency set by DCOX plus 1. When DCOX is equal to 0107 hexadecimal value, the mod X bits have no effect because the DCO is already at the highest setting for the selected RSEL range. I hope you would have learned from this clock signal video. See you in the next video. Until then, it's bye from Radhika.